Problem-solving strategy using a simulation. In this lesson, you'll use to investigate problems using simulation. Let's take a look at this example. Paiute Indians of Pyramid Lake in northwestern Nevada invented the walnut shell game. This game was played with 8 walnut shell halves filled with pitch and powdered charcoal. A player tosses a basket tray containing the walnut shell halves and scores 1 point if 3 or 5 of the walnut shells land the flat side up. No point is scored for any other combination. The winner is the first player to reach an agreed on sum. On average, how many times would you have to toss the basket before you get 10 points? Okay, and this is a good way of finding the probability of an event by actually doing it. So, if you have the time, work with somebody to simulate the walnut shell game. Basically, what you need to do, place 8 pennies in a cup, put your hand over the cup and shake it gently. Then pour the pennies out. Record the number of heads in the frequency table, like the one shown here, like this one right here. Okay, outcome, tally, frequency, uh, and what you come up with, heads or tails. Okay, number of heads. Repeat the process until the sum of the frequencies for 3 heads and 5 heads is 10. Compare results to other pairs of students. Do you think this process is a reasonable approximation of the walnut game? Okay, so the answer of this, of course, would be yes, because you are actually going through the process. So it's nothing better than actually going through the process because you get actual results. Okay, what's the advantage of finding the answer by acting it out? And a good answer might be you may be able to find an approximation for a complicated probability. So if you have a probability that's pretty much complicated, all you need to do is act it out, and your probability is there. No more memorizing formulas and all that stuff. Okay, so that's a good way of using a simulation to find the probability of an event happening. Okay, so when you solve a problem by modeling a situation like you did in the activity above, you are what we call doing a simulation. Definition of a simulation, okay, acts out the event so that you can see the outcomes. Okay, simulation is an application of acting it out and problem solving strategy. So this is one way of finding the solution to a problem by actually creating a simulation or acting it out. You can conduct a simulation of outcomes of many problems by using manipulatives such as dice, a coin, or a spinner. The manipulatives such as a die, a coin, a spinner, or a combination of them, okay, should have the same number of outcomes as the number of possible outcomes. Okay, what does that mean? For example, in a real world event, having a baby boy or baby girl, there are 2 possible outcomes. So the simulation might be flipping a coin. The history of making 2 free throws for every 3 attempted, since there are 3 possible outcomes, you need a spinner that has 3 sections with 2 sections with the same color. The 2 sections obviously will represent the 2 free throws made, okay, and the 3 sections will represent the 3 attempts. Okay, another real world event, win 1 of 12 prizes. So again, you have an outcome of 12 prizes, and you want to win 1. Okay, so roll a die and flip a coin. Why is that? Because when you roll a die, you have six outcomes. When you flip a coin, you have 2 outcomes. Multiply that according to the fundamental counting principle. 6 times 2 will give you 12, and that's how you get your 12. Okay, so if you look at this one, rolling a die will give you 6 possible outcomes. Flipping a coin will give you 2 possible outcomes. Multiply that, you'll get That's how you get your 12 prizes. Okay, so those are manipulatives that you can use to find the probability of real world events. Okay, let's take a look at this example. A quiz has 10 true or false questions. The correct answers are TFF, TFF, TTTF. Okay, those are all the answers for true or false questions. You need to correctly answer 7 to pass the quiz, 70%. Is tossing a coin to decide the answer is a good strategy for taking a quiz? Okay, let's say you completely did not study for the test and you were very much unprepared and you got a coin in your pocket. If you toss a coin, would that be a good strategy to take the quiz? Okay, let's find out because now you're using a simulation. The quiz has 10 questions. Since two choices are available for each answer, tossing a coin is used to simulate guessing the answers. Tossing a coin is a good manipulative to use to be able to simulate this kind of a problem, okay, for guessing answers. Toss a coin and record the answer for each question. Write T for true if tails shows, and F for false if head shows. Repeat the simulation 3 times, shade the cells with the correct answer. Let's say you do this, okay, and you have a lot of time to waste and you did not study, so you do this 3 times. And this is an example of an actual simulation. Simulation 1, okay, after tossing the coin 10 times, you come up with 4 correct answers. In simulation 2, you come up with 5 correct answers, and simulation 3 come up with 6 correct answers. If you notice, all 3 simulations would give you a failing mark. Okay, since none of the simulations results in passing grade, this is probably not a good way to take a quiz. Okay, and you want to try more simulations to check or to confirm the results of what you just did. Okay, so that's an example of a simulation and how to use manipulatives to be able to find the probability of a particular event happening. Take a look at example number 2. Sometimes it is necessary to create a manipulative for a simulation. In example 2, that is exactly what we are going to do. The Cougars are 1 point behind their basketball game. Carmen is fouled as time runs out. If she misses the foul shot, the Cougars lose. If Carmen makes the foul shot, the score is tied and she gets another shot. If she makes the first and second shots, the Cougars win. Carmen has a record of making 3 out of every 4 free throws. Okay? So, let's find out how we can conduct a simulation for 25 trips to the foul line. Okay? Let's see. So we want to first construct a spinner with 4 equal sections like the one shown at the right, this one right here. Okay? Why are there 3 blues? These are the 3 baskets that she can make, the 3 free throws that she can make, because she can make 3 out of every 4 free throws. Okay? Spin the spinner and record the results of several trips to the foul line. Sample simulation for 25 trips to the foul line is shown in the chart below. Okay, so misses the first point, you make tally marks. Okay, so every time you spin a spinner and it lands on the blue, the basket is made. So you record that. Okay, spin the spinner and record the results of several trips to the foul line. Sample simulation for 25 trips to the foul line is shown at the chart below. So spin this 25 times. Okay, misses the first shot, 0 points. Okay, tally marks here. Every time you spin the spinner, you make a tally mark. And if you notice at this point, okay, makes both shots. The tally marks here indicate 17 times that she makes 2 points. 4 times that she makes only 1 point, and 4 times that she makes no points. Okay, so what is the probability that Carmen makes both shots and the Cougars win the game? The experiment shows that Carmen will make 2 points 17 out of 25 times, or 68% of the time. Based on this simulation, the probability that Carmen scores 2 points and the Cougars win is 68%. So that's how you find the probability, by using a simulation. If you notice, okay, the probability of her making the free throw is not 68%. When I say the probability, I'm talking about theoretical probability, because in the example, it says there that she can make a free throw 3 out of every 4 free throws. So that's 3/4. Okay, so the probability of her making it will be 3/4, or 75%. This is the theoretical probability. What we did, okay, was a simulation, or the actual event, as we tried 25 times. There is a slight difference between 75% and 68%. Okay, so the simulation is not really the same with the theoretical probability, but they should be close enough to each other. Okay, lessons done. On Google Forms, type a summary of what you've learned, responding to the objective of the lesson, and type a question you might want to ask in class about this lesson. Thank you.